let us start lecture 21. As we have ended lecture 20, saying that we would construct a simple pourbaix diagram, and we will take an example with nickel H2O system. So, our job today is to find diagram of nickel or nickel H2O system. So, for that we have to see what are the reactions that are possible for nickel in H2O system, and we can see that all the reactions can be categorized in terms of type 1, type 2, type 3, as we have discussed in our last lecture. So, the first type what we can think of is basically the type 1 reaction, which is nickel plus 2E nickel. This reaction, which is function of potential, but not a function of pH, since there is no hydrogen ion involved in this reaction. And in order to find an equation which will give an idea about this reaction, which is the Nernst equation, E Ni equal to E0 Ni plus RT by 2F ln activity of Ni plus activity of Ni. See, it will follow ox slash red, and we will consider 25 degrees Celsius, 1 atmosphere pressure. So, this quantity, and then if we convert this one to log, then we will get following factor: log of 0.0591 by 2. Here 2 is coming from 2 electron that is involved in this reduction reaction. Now, the next step is we have to find out this quantity, and in order to find out, we have to find out delta Z0, which is nothing but chemical potential, rather standard chemical potential of product minus standard chemical potential of Ni plus plus. And we have the knowledge of chemical potential of standard chemical potential of nickel as well as Ni plus plus ion. Ni equal to 0, mu 0, Ni plus plus is equal to 48250 joule per mole. So, we get, so there is a minus sign, so 0 minus, so minus, and this minus would become plus 48250. So, which is to be equated to minus 2F E0, and in this case E0 is this. So, we get E0 equal to 48250 2 into 96,500 equal to 0.25 volt. And then we can modify this equation. Instead of this quantity, we can put this 0 point with a minus sign, 0.25. So, we can have a plot for this equation on E versus pH. So, here unit is volt. Now, this is minus 0.25 volt. When conditions, let us say, let us put several conditions. Condition 1, activity of Ni plus plus equal to 1, and since activity of Ni is 1, then E equal to this condition, E equal to minus 0.25. So, it will be a parallel line parallel to pH axis. So, we get this line. So, at all the pH values we can plot this equation E equal to minus 0.25, and that time condition is activity is equal to 1. So, here I am putting activity or A1, the condition 1, I would say condition 1. So, AI equal to 1. Now, let us see what happens if we have Ni plus plus equal to 0.5, and of course, ANI equal to 1, since it is a solid, pure solid. So, E Ni plus plus Ni would become minus 0.25 minus plus 0.0591 by 2 log of 0.5, which eventually becomes minus 0.26. So, if I give it a color, so this becomes my A2 equal to 0.5. Now, we can have another set A Ni plus plus equal to 0.1, and that time A Ni equal to 1. So, that case E Ni plus plus Ni equal to minus 0.25 plus 0.591 by 2 log of 0.1. So, it becomes minus 0.28 volt. So, this is also volt. So, here also we will have a plot which is A3 equal to 0.1. So, for each activity of nickel ion in the solution, we see that we can construct a line to indicate this reaction on E versus pH plot, and this lines will be parallel to pH axis, because since there is no pH term in this equation. So, now question is, whenever we have this line, we have to also see the stability of two species. Here the stability means this one and this one, these two species are there. Now, question is, which side would be my nickel and which side would be Ni plus plus. For that, let us assume that for a particular solution we can measure the concentration of ions, because once we have nickel in water, we will see that nickel plus plus ion is forming. Now, let us say 10 to the power minus 6, that is the concentration of, or in other word let us say activity Ni plus plus is equal to 10 to the power minus 6, that is the limit up to which we can measure the activity of Ni plus plus. But once the activity of nickel ion is less than 10 to the power minus 6, then we will not be able to detect anything. What does it mean? So, if we cannot detect anything, so we would say that as if there is no nickel ion. So, then if there is no nickel ion, that means the nickel is present only, no ion is present. This is one part. Second part is, we see that as the activity of nickel ion concentration is decreasing, that means as we see that it is decreasing, we are seeing that these lines, these 1, 2, 3 lines, you see the lines are dropping down. So, they are going down. So, that means if we go for 10 to the power minus 6, it will go farther down. So, we can also calculate what could be that potential. So, that potential would be definitely E Ni plus plus Ni equal to 0.25 plus 0.0591 by 2 log of activity of nickel ion is 10 to the power minus 6. We can find out some value. So, it will be farther down. So, for that we can have another plot. So, this could be let us say here, where A is equal to 10 to the power minus 6. So, that means, but question is, if we go farther down, if let us say activity is less than 10 to the power minus 6. So, what could be the potential? So, that potential would be less than the potential at 10 to the power minus 6. Now, we see that 10 to the power minus 6 is my limit to measure nickel ion concentration. Then of course, when we achieve this situation, we will only see nickel. Now, if I redraw that particular diagram, this is pH, this is E volt. So, we get this is A equal to 1, this is A equal to 10 to the power minus 6, and now some A less than 10 to the power minus 6. Had we measured this concentration, we would have potential here at this point, but here we are not able to measure nickel ion. So, that means nickel is only there. What does it mean? That below this line we have nickel, because we are not able to detect any concentration below 10 to the power minus 6. Now, let us say we assume that we cannot measure a concentration A if it is 10 to the power minus 4. If we say that activity below this, we are not able to detect any nickel ion. So, we would definitely say that below this activity 10 to the minus 4, there would be all the things will be nickel. So, what does it mean? That means line below this only nickel is present. So, what happens on top of it? So, on top of it definitely we have nickel ion. So, this is nickel ion and here it is nickel. So, if I try to see again, so any line which indicates that reduction reaction for nickel ion reduction, which is parallel to pH axis, below that line we have nickel and above that line we have nickel plus plus. Now, interestingly, as we decrease the activity, we are actually extending the nickel ion stability. So, this is activity equal to 1 and then this is the activity equal to 0.1. Like that way, as we are decreasing activity of nickel ion or detectable nickel ion, we are extending the nickel ion region and contracting the nickel region. So, then of course, the bottom part would be bottom part of this line would be definitely nickel, and top part would definitely be Ni++. So, now we are clear that which side is nickel and which side is nickel ++. So, this is the situation for the first reaction, which is type 1 type, where we have potential dependency, but it is pH independent. We can now we have two species, one is nickel, one is nickel ++. So, the nickel ion can react with H2O and then form NiO. This reaction is possible, and this reaction you see that whenever nickel is forming, nickel ion is first forming, and then that would again react with H2O to form NiO. Interestingly, if we see the forward reaction, it is an oxidation reaction, but if we see the backward reaction, it is a reduction reaction. So, since we always consider the reduction reaction in order to find out potential, so we can write this entire reaction reverse. So, it becomes nickel oxide 2H plus 2E equal to Ni plus H2. So, this side is oxidant and this side becomes reductant. And similarly, for nickel ion, we can also react with H2O and then form nickel OH whole 2 plus 2H plus. We can have this reaction. Now, interestingly, you see that this reaction is type 2 and this reaction is type 3. Now, we can also construct another nickel plus H2O, it can form NiOH whole 2 plus 2H plus 2E, or we can write reverse NiOH whole 2 plus 2H plus 2E equal to Ni plus 2H2O. This is also type 2. So, that means we see that we again have two types of reaction, one is type 2 and one is type 3. This reaction is pH as well as potential dependent. This is only function of pH and not a function of potential. Since here only we have H plus ion presence, but no electrons are involved in this reaction, and but here we have electron involvement as well as hydrogen ion involvement. Now, first look at this type of reaction. So, first consider this is a simple type, let us consider that. So, when I consider that, so NiO plus 2H plus 2E equal to Ni plus H2O. Now, we have to find out a Nernst equation for this. So, Nernst equation, so I am not writing ox and reduct like that. So, this is the oxidation, the left side is oxidation part and right side is basically the reductant part. So, E0 plus RT2F ln activity of NiO, activity of H plus square, activity of Ni and activity of H2O. Now, since this is a solid and it is a pure solid, so it is 0, this is 0, this is also pure 0. So, we are left with AH plus. Now, if we assume that the system is maintaining ideality, so AH plus we can consider with the concentration, and then if we convert ln to log, so we can write the entire this particular stuff. In addition to this, we can write E 0 plus 0.0591 by 2 into 2 log of H plus, or E 0 minus 0.0591 pH, since minus log of H plus equal to pH. So, we can plot this reaction, this equation on a E versus pH plot. Now, definitely this is a negative slope. So, if I try to see E versus pH, so at pH 0 I would get E 0, and then as the pH is changing, so there would be a straight line. This is a plot of a straight line with a slope minus 0.0591. So, we have to find out E 0. So, E 0 is nothing but NF, and here NF is 2F because there are 2 electrons involved. Delta G 0 equal to summation of chemical potential of, which should be product reactant. So, then mu of nickel, mu 0 of H2O minus mu 0 of NiO minus 2 mu 0 of H plus. So, again we know that mu 0 Ni equal to 0, mu 0 H plus equal to 0, these are convention. Now, mu 0 H2O is equal to minus 236,964.2 joule per mole, and mu 0 NiO equal to minus 215729.8 joule per mole. Then minus 236,964.2 plus 215729.8 is equal to minus 21234.4. Therefore, E 0 would be equal to minus 21234.4 divided by 2 into 96500 is equal to 0.11 volt. So, for this line, this point would be 0.11 volt, since when pH is equal to this equal to 0, then E equal to E 0. So, we do get a plot. Now, which side would be nickel and which side would be NiO? Definitely this side would be nickel and this side would be NiO. Now, we see that this side, we have said that this side is nickel and this side is nickel oxide. In our next lecture, we will understand why below this line we have nickel and above this line we have nickel oxide. So, let us stop here. We will continue our discussion on pourbaix diagram of nickel in our next lecture. Thank you.